What's up, guys? We're going to go through a couple examples from the quiz review to make sure that you understand some of the more challenging questions. So, number 3 says find the equation of the line tangent to the function at the given point. Your answer should be in slope-intercept form. So we actually saw a question in the 2.4 lesson today that was similar to this. So really you just need to read this as, if I'm finding the equation of a tangent line, I need to first find the slope of the tangent line, which is done by using a derivative. So the first thing you're going to do is you're going to take the derivative, which would be 2x plus 4, and then you're going to evaluate that derivative at the given point. So in this case, you're going to take the x coordinate and you're going to plug that in to find your slope. So we would have -6 plus 4 would be -2. And then after that, you're going to set up your point slope form. And you're going to get y alone. I believe it should be y equals -2x minus 10. All right, given the graph of f of x, sketch the graph for f prime of x. So that means that this graph you're drawing is going to represent the slope of the graph on the left side. The way we did this in class is we identified some points and we made a table. Except instead of an XY table, it would be an X slope table. So I think I'm going to do it the same way. I'm going to pick a few points where the graph is kind of changing. The slope is changing, and I'm going to find what I think the slope is at those locations. Okay. So there's no science to this. I'm just picking random points. So I'm going to start at the beginning and say when x is -6, the slope looks like it's pretty small, but it is positive. So maybe I'll call that, 1/4. And then at -2, the slope is still pretty small, but a little bigger than the last point of interest. It is still positive. At -1, again, the slope seems to still be increasing. So maybe I'll call that 1. At 0, the slope is increasing again. Maybe I'll call that one 2. And then the slope at 1/2 looks like it's getting pretty large. So maybe I'll call that like 6. It kind of, just whatever you think makes sense there. And then at 1, you have an asymptote. So there's no slope identified there. So we know that this is not going to have a value right here in the center. And then I'll just pick up kind of where I left off at the other side. So I have at, 1.5 maybe was the x value. The slope looks like it's positive and it's a pretty big number, kind of like up here. So I'll go 6 again. And then at 2, it starts to slow down a bit. So maybe I'll call the slope there 2. At 2.5, we're back down a little bit, maybe closer to like 1.5 or 1. When x is 4, it looks like the slope is getting smaller, so maybe I'll go to 1/2 for that. And then when we get to 6, the slope has really slowed down, so I'm going to call it 1/4, kind of like what I did up here. So once you've got this identified, you can just plot these points. And keep in mind that these points are not exact values because you estimated those slopes. So be prepared for your line to not look like it's a nice smooth curve. And you may have to just kind of mess with it a little bit to make it look more uniform. So once I get all my points plotted, then I'm going to attempt to make it look like a nice smooth curve. Keep in mind I'm using my airliner, which is really hard to draw on. Okay, you get the idea. Kind of looks like like a reciprocal function like what we have over here, but this part's flipped up. Okay, now this one, what you're doing is the opposite. So this graph over here is the derivative, and this is the original function. So I want to draw the graph of the original function. I have to keep in mind that on this derivative graph, all of the y values are slope values. So if I'm looking at like this point here, this point means that when x is 0, the slope is approximately equal to 2. Okay, so when I draw my graph, I'm going to try to draw a line that represents a slope of what I think is 2. So I'm going to identify some key points, kind of where I see values changing. And then we can sort of try to put everything together. Okay, so I'm going to make a table again. But this time I think I'm going to do an x slope table like before to kind of write down these values. So remember, the y value on this graph represents the slope. So when x is -7, the slope is about -1/4. That's the y value there. When x is -3, the slope, the y value, is at 0. Okay, so remember, when the slope is 0, this is like a min or max. When we get to x equals -1.5, our slope is, the y value, remember, is 1. When we get to 0, our y value, which represents our slope, is about 2. And then at +1.5, we'll say, the slope is back down to 1. And then when we go to x equals 3, the slope looks like it's, the y value again is at 0. And then when we go to the end at 6, or maybe I'll do 7 since that was the same as the left side, the y value there is about -1/4 again. So we have to try to take all this information and put it into a graph. And keep in mind, we don't really know what the actual y values are on this graph. All we know is that we have a negative slope, and then a 0 slope, and then positive, and then 0, and then back to negative, okay? So the way I'm going to read it is I'm going to say, okay, from -infinity to -3. If I look right here at the beginning of my table, from -infinity to -3, the function is decreasing because the slope is negative there. At -3, we have a max or a min because the slope is 0. Then from -3 to +3, our slope is increasing. Our function is increasing a little bit. And then at 0, or not 0, sorry, 3. At 3 again, we have another max or a min because the slope is 0 there. And then when we go beyond the x value of 3, the slope is back to a negative. Okay. So I'm going to try to make all this happen in one graph. So again, it doesn't matter what y value you start at. It's more about like the shape of the graph. So I want my graph to start with a really, almost a flat line, but slightly decreasing. And that is about at -7. So over here, my graph is kind of slowly decreasing. Well, slowly decreasing, and then at -3, my graph has a minimum. So I'm just going to choose to put that there. But there has to be like a minimum value here. Okay, so really small slope, slightly decreasing until -3, and then it's got a min. And then from -3 to +3, my graph is going to increase. Now look, 2 is the highest the slope goes. So you have a line that's kind of steadily increasing, steepens a little bit, and then kind of levels out. So we're going to have, it's not so steep, steeper, not so steep. See how I did not make my line go down? This is kind of supposed to be curved. Let me try that again. I don't want to make my line go down because it's not supposed to be decreasing here. I just want to make it kind of go a little steeper in the middle and then kind of flatten out. Almost like it's concave up here and then concave down. And then I need a maximum again at +3. So we'll put it here. So there's our maximum value. And then we want to level, we want to go back down, right? We want to be decreasing again, but just ever so slightly. Okay? So like that. Okay, these two questions are asking you to be abstract in your knowledge of derivatives. So it says for 18, part 1, h is equal to f plus g, find h prime of 3. Okay, so if I want to take the derivative of something that's a sum or a difference, I am allowed to just take the derivative of each piece separately and put a plus sign between. So once you do that, you're going to plug 3 in. And then you're going to go to your table and find these values. So f prime of 3 is -3/2. And then g prime of 3 is -1/2. So I have -3/2 plus -1/2 would be equal to -4/2, which is -2. Down here, however, they're asking you to do something very similar, except your first function is a product and your second function is a quotient. So you will have to use product rule and quotient rule for these two questions. Just remember, you're going to make whatever is first u and whatever is second v. So u prime v plus u v prime would look like this, and then you will plug in ones in this case and go find your numbers from the table. So f prime of 1, get some more space here. F prime of 1 is, hold on. F prime of 1 is 2. No, wrong table. Jeez. F prime of 1, oh, it is 2. Okay. G of 1 is 2. F of 1 is 1. And G prime of 1 is 2. This is 4 plus 2, so 6. And then part 2 of this one is a quotient, so you would just use quotient rule for that one. Last question. This is a limit question. So in order to do this, you would have to use all your limit rules like plug and chug, factor and cancel, conjugate, whatever tricks you can use to evaluate the limit, use them. In this case, there's no factor and cancel. There's no conjugate because I don't have a radical. Really, the only thing I can do is like multiply all this out and kind of hope that it gets me somewhere. So I just wanted to show you this example in particular because it's at h to the third power. So I have to multiply these two, like two things at a time, and then do it again. So this would be 1/9 plus 1/3, so 2/3 h plus h squared, and then I got to multiply that by 1/3 plus h one more time. So that would be 1/27 plus 1/9 h plus 2/9 h plus 2/3 h squared plus 1/3 h squared plus h to the third. And then I do have this last part I need to put after that. So minus 1/3 cubed would be 1 over 27. And this whole thing goes over h. And so you're going to look for things that cancel, which there's not that many. Those two items do cancel. And then if you look at all your terms you have left, you do have like terms. So I'm going to combine those. 1/9 h plus 2/9 h would be 3/9, which is equal to 1/3. H squared 2/3 plus 1/3 is just 1. And then only an h to the third term over h. And this is good because I do see that there is an h I could factor out of each item on the top. So I have 1/3 plus h squared, and then I can cancel the h on the bottom. So now, once I've gotten this far, I'm going to plug and chug, and I'm plugging 0 everywhere that I see an h, and that's going to leave me with just 1/3.